In this chapter, you are going to learn about recognize carbon, appreciate the existence of large number of carbon compounds, sources of carbon compounds, allotropes of carbon and their properties, describe the preparation of oxides of carbon, recognize catenation, saturated and unsaturated hydrocarbons, recognize different functional groups. Lastly, appreciate that organic compounds and some of their uses. So let us study what do you mean by carbon. Carbon is present in all life. Carbon is present in carbonate rocks, that is limestone, dolomite, marble, etc. The carbon is present everywhere. It is present biologically as well as physically. It is present in all organisms, in all life, as well as physically. It is present in most of the carbonate rocks, that is in the form of a limestone, dolomite and marble, etc. So we can say that carbon is present everywhere in this nature. There are three naturally occurring isotopes of carbon. So in this nature, the carbon occurs in the form of isotopes. We already studied what do you mean by isotopes, that is which have same atomic number but different mass number. So here the carbon is having three isotopes. What are those? Carbon 12, carbon 13 and carbon 14. So these are the three isotopes of carbon. So carbon is having, why carbon is so special, right? Why we have to make a single chapter about the carbon and its compounds? It is because of it is having some special properties. Let us study about it. One of the most important property. So the unique property of a carbon is forming long chains. Forming long chains, and this property is known as catenation. So what do you mean by catenation? It is nothing but it is a unique property, or you can say it is a special property of a carbon to form a long chains. You can see the diagram above, right? You have a very long number of carbon, so it is never ending. So what do you mean by long chain? So it is very long number of carbon atoms can form a, so this specific property is having only for carbon. So that property is called as a catenation. Why do the carbon has this property is because again carbon is a tetrahedral in nature. It is having tetravalency. So that is one more specific property of a carbon. It is having a 4 valency. It can combine with the 4 atoms. So it can have a catenation property. So these are some of the special properties of a carbon. We have a special branch of a chemistry to study the number of carbon and its compounds. So the number study of compounds, the number study of the compounds is called as an organic chemistry. So we have a specific branch of a chemistry called as organic chemistry. It deals with specially to study the compounds of a carbon. Now we will understand a special important concept, that is allotropy. What do you mean by allotropy? The existence of a chemical element in 2 or more forms, which may differ in arrangement of atoms in crystalline solids. So what do you mean by allotropy? So allotropy is nothing but it is a existence of an element in 2 or more forms. A single element will exist in 2 or more forms. So they may differ either in the arrangement of atoms. How do they differ? They differ in the arrangement of atoms, though it is a same element. So that specific property is called as an allotropy. There are three allotrophic forms. There are three allotrophic forms of carbon, that is graphite, diamond, and fullerenes. So these are the three allotrophic form of carbon. Again, we say that the special property of a carbon is allotropy. It exists. It is having three allotrophic forms. So let us study all the three allotrophies of carbon. Firstly, we move to the diamond. In a diamond crystal, each carbon atom is linked to four other carbon atoms by covalent bonds in a tetrahedral fashion, right? This results in a three-dimensional arrangement. So we all have heard about a diamond. So it is one of a allotropy form of a carbon. So how the atoms are arranged there? The carbon atoms are arranged in a tetrahedral fashion. They are arranged in a tetrahedral fashion. We will study some of the important characteristics of a diamond. So here at the right side you have a diagram of a diamond, right? So how they are arranged? They are arranged in a tetrahedral in fashion, as we have already studied. The diamond where four carbon atoms have been arranged in a tetrahedral fashion. So let us study some characteristics of diamond. Diamonds are basically colorless. Diamonds are basically colorless. They do not have any color. The density of a diamond is high. It has a value of 3.51 grams per cubic centimeter, and its melting point is also high. The melting point of a diamond is about 3500 degrees Celsius. So how much it is? 3500 degrees Celsius. The only other substance harder than diamond is silicon carbide. So it has been usually in a heating furnace, silicon carbide. So it is one of the hardest substance. So diamond is the hardest, other than diamond is a silicon carbide. So these are some of the important characteristics of a diamond. We will see some of the uses. Diamond is used in cutting and grinding of other hard materials. So it is used in cutting and grinding of other hard materials. Especially we cut the glass using the diamond. It is employed in instruments used for cutting of glass. Yes, it is used for the cutting of glass and also for drilling of rocks. It is also used for drilling of rocks. And obviously it is used in, so some of the most uses of a diamond. We will move upon to the next important allotropy of carbon. Graphite, right? So we have another important allotropy, graphite. Graphite is soft, black, and slippery solid. It has a metallic luster. It is also a good conductor of electricity and heat, right? So what is a graphite? It is basically texturally, it is very soft, black, and slippery. It is solid in nature. It has a metallic luster, means it is a shining. It has a shining property, and it is a good conductor of heat and electricity. Now, at the right side, you have a structure of a graphite, right? So what is this graphite structure? So let us study how is the structure of a graphite. Graphite contains layers of carbon atoms. It has a layers of carbon atoms. In each layer, a particular carbon atom is linked to three other carbon atoms in a triangular planar arrangement with a bond angle of 120 degree. So here, as in the case of diamond, we have a tetrahedral structure, whereas here we have a triangular form. In case of graphite, we have a triangular planar arrangement where the each of the carbon is linked to the other three carbon atoms. So they are in a form of a layers, one above the another. So these layers are being forming a bond angle of 120 degree. So here, between each layer, the bond is very smooth. You can see the light blue color, right? So bonding is very weak. So whenever you press it, the graphite will break. So only we say it is very soft. The best example for graphite is pencil lead. So only it will break so easily because the bonding between the layers of a graphite in a carbon atoms is very weak. We will study the next important allotropy of carbon. Fullerenes. So what is this fullerene? A typical fullerene named as a Buckminster fullerene has 60 carbon atoms. So at the right side you can see that is a structure of a fullerene, which is an allotropy form of carbon. So you can see the ball-like structures in that picture. You can see a ball-like structure. They represent the carbon atoms. So each fullerene contains 60 carbon atoms. They are being arranged in a form of a ball. So we call it also as a Zucker's ball. We also call the fullerenes as a Zucker ball, and it is also named as a Buckminster fullerene. The next important allotropy of carbon is charcoal. So we all know charcoal. A charcoal is formed when wood is heated strongly in the absence of air. It is widely used for absorbing colored impurities and bad odors from water. So it is one of the another important allotropy of carbon. So how it is formed? By burning of wood in a absence of air. In the absence of air. So this is about the charcoal. The next allotropy of the carbon is that is coke, right? So what is a coke? It is an impure form of carbon, right? So it is also another allotropy form of carbon, but which is present in a form of impure form. So coke is also a allotropy form of carbon. Now we will study some of the important compounds of a carbon. So important compounds of carbon, we have two types of compounds of carbon, that is organic and inorganic compounds. So we already have studied in previous chapters what do you mean by organic, what do you mean by inorganic compounds, right? So we'll study now in detail. Organic compounds were defined as those compounds which originated from living organisms. So the name itself suggests. So these are the compounds which are originated from the living organisms. The compounds of carbon which are not organic compounds. What do you mean by inorganic? Which are not organic compounds are called as inorganic compounds. Or else in another way we can say the compound which are not originated from living organisms. For example, for the inorganic compounds, limestone, marble, dolomite, which carbon as a carbonates. They contain carbon as a carbonates. So these are some of the inorganic compounds. We will move upon the oxides of carbon, right? We have two important oxides of carbon. What are those? Carbon monoxide and carbon dioxide. So these are the two important oxides of carbon. We will study about the carbon monoxide, right? So carbon monoxide is formed when carbon or hydrocarbons are burned in a limited supply of oxygen, right? So carbon monoxide is formed whenever we burn carbon or a hydrocarbons in a limited supply, means less supply of oxygen. It is colorless. How it is? It is basically colorless and odorless. It do not have any smell, right? And it has a melting point of minus 199 degrees Celsius, and it has a boiling point of about minus 192 degrees Celsius. So these are some of the important characteristics of carbon monoxide. When we see the chemical reaction for the formation of carbon monoxide, when a carbon combines with the oxygen, so oxygen is in the form of a gas, it results in the formation of a carbon monoxide, right? CO, that is a carbon monoxide. Next, we'll move upon to the next important oxide of a carbon, that is carbon dioxide. Carbon dioxide is formed when carbon containing substances are burnt in excess of oxygen, right? So here the carbon dioxide is being formed when we burn the carbon containing substances in excess of oxygen. So let us see the reaction. When carbon combines with the oxygen, it results here, the oxygen is excess, right? It results in the formation of a product that is carbon dioxide. So this is how we can prepare the two dioxides of the carbon, that is two oxides of carbon, that is carbon monoxide and carbon dioxide. Solid carbon dioxide, it is also called as dry ice, right? It is also called as dry ice, is used as a refrigerant because when it is cooled at atmospheric pressure, it condenses into a solid rather than a liquid. So whenever we cool it at atmospheric pressure, it condenses into a solid than a liquid. So we use it as a refrigerant. So only it is called as a dry ice. It is used in the production of a carbonated drinks. So we know we have so many carbonated drinks. So it is used in the production of carbonated drinks, and it is also used in the production of washing soda. It is also used for the production of washing soda. That is sodium carbonate. We will study about the hydrocarbons, right? So we have two forms of hydrocarbons. Let us study about aliphatic hydrocarbons. What do you mean by aliphatic hydrocarbons? hydrocarbons. So at the right side, you have three forms of aliphatic hydrocarbons. The word aliphatic is derived from a Greek word, alipher, meaning fat. Alipher meaning fat. Aliphatic hydrocarbons were named because they were derived from the fats and oils, right? So the main origin of the aliphatic hydrocarbons is the fats and oils. So only they have got the name, that is aliphatic hydrocarbons. So here you can see at the right side, we have three forms of aliphatic hydrocarbons. What are those? Alkane, next one is a alkene, last is a alkyne, right? So we will study each one of them. Before studying in detail about aliphatic hydrocarbon, let us study next important hydrocarbon, that is aromatic hydrocarbons. The word aromatic is derived from the word that is aroma, meaning fragrance. So what do you mean by aroma? Meaning fragrance. The aromatic compounds have a characteristic smell. They have a special smell, characteristic smell. Structurally, they include benzene and its derivatives, right? So structurally, they include a benzene. At the right side, you have a closed ring-like structure. The diagram, right side, right? You have a closed ring-like structure. So that closed ring is called as a benzene ring. What it is called as? Benzene ring. So usually the aromatic hydrocarbons, structurally, they include the benzene ring or their derivatives. So this is about the two hydrocarbons, that is aliphatic and aromatic hydrocarbons. We will study them in detail. The aliphatic hydrocarbons can be divided into two categories. They are divided into two categories. What are those? Saturated hydrocarbons and unsaturated hydrocarbons. So what do you mean by saturated hydrocarbons? Saturated hydrocarbons are also called as alkanes. They are also called as alkanes. In saturated hydrocarbons, carbon atoms are linked to each other by single bond, right? So aliphatic hydrocarbons are in the form of a chains, right? So here in again alkanes, that is saturated hydrocarbons, each of the carbon are being linked by single bonds. That is very important. They are linked by a bond. So in alkanes, the best example for the alkane is methane. Methane formula CH4 is the simplest alkane in which the four hydrogen atoms are linked to the carbon atom in a tetrahedral fashion, right? Tetrahedral in the sense the carbon is linked to the four hydrogen with the four single bonds. They are being linked by the four single bonds. So it comes under saturated hydrocarbons. Methane is the simplest alkane. Now these alkenes will exhibit some of the special property called as isomerism. They are also called as isomers. So what do you mean by isomers? Isomers are the compounds which have same molecular formula but have different structures, right? These are the again they are the saturated hydrocarbons or they are the alkanes which have same molecular formula. Formula will be same but they are different. So those are called as isomers. What are unsaturated hydrocarbons? We studied about saturated. Now, unsaturated hydrocarbons, they are the carbon atoms linked to each other by multiple bonds. So, multiple in the sense, it might be double bond or it might be a triple bonds. So, as in a case of saturated, the carbon atoms are linked by single bonds, whereas in case of unsaturated, they are linked by the multiple bonds. Either it may be double or a triple bonds. So we have in unsaturated alkenes, right? So they're alkane, the ending A and E, here E and E is alkenes. The simplest alkene, that is ethene, has two carbon atoms joined by a double bond. So here the carbon atom is linked to the hydrogen atoms by double bond. Its molecular formula is C2H4. So here two carbon atoms will link with the four hydrogen atoms by the double bonds. So it is a type of a unsaturated hydrocarbon. So we have another type of unsaturated hydrocarbon, that is alkyne. The simplest alkyne is ethyne. So it is a ethyne. It has the carbon atoms which are joined by triple bonds. It has a carbon atoms joined by the triple. Its molecular formula is C2H2. So what is of here? The two carbon atoms will share only two hydrogens by forming the triple bond. So they are called as a alkyne. They again come under unsaturated hydrocarbons. So we studied the types of hydrocarbons till now, that is aliphatic and the aromatic, and again in that we have studied in detail about aliphatic and aromatic hydrocarbons. Now we will move upon to the next important topic, that is a functional groups. The carbon is been linked with the special functional groups. Some of the functional groups like alcohol. What is this alcohol? So we will take an example of an alcohol, that is methanol. So methanol here you can see methane formula CH4 where one hydrogen has been removed and it has been substituted by a functional group, that is OH, that is CH3OH. So methane became methanol. So what is this methanol? The methanol is called wood alcohol. It is called as what? Wood alcohol, because it was earlier obtained by heating wood in the absence of air. So it was obtained by heating wood in absence of air. So it is called wood alcohol. It is used in synthesis of acetic acid. It is used in the synthesis of acetic acid and many adhesives, fibers and plastics. So these are some of the uses of methanol. At the right side, you have a structure of methanol, right? So here, what is a methanol? Which has a functional group as alcohol, which has a functional group, that is alcohol. Here OH is the functional group. OH is the functional group. We will study the next important functional group, that is aldehyde. You have the aldehyde. So at the right side you have a diagram diagram of a functional group, the aldehyde. So the simplest form of aldehyde is a formaldehyde. Formaldehyde is the simplest form of aldehyde. CHCHO. It is a colorless, strong smelling gas used in making building materials and many household products. It is used in pressed wood products such as glues and adhesives, right? So you have some of the smelling gases, strong smelling gases. Usually they contain the aldehyde. They contain, even in some of the glues and adhesives, you have some of the smell. It is because of presence of formaldehyde. So what is this formaldehyde? A hydrocarbon having the aldehyde as a functional group is called as a formaldehyde. So here at the right side, you have a functional group that is HCHO. It is a functional group of aldehyde. So the next one is ketone. The most common ketone. So what is the functional group of ketone? C double bond O. The most common ketone is an acetone, which is an excellent solvent for a number of plastics and synthetic fibers. So it is one of a solvent. We can dissolve most of the plastics and synthetic fibers. So that is acetone. In household, acetone is used as a nail paint remover and paint thinner. So you might be using, most of you, that is nail paint remover. It consists of acetone. So what is a functional group of acetone? That is a C double bond O, which is a functional group called as a ketone. The next important functional group of carbon is carboxylic acid, right? You have a important functional group, carboxylic acid. Formic acid, that is HCOOH. So this is one of the functional group of carboxylic acid, HCOOH. The simplest carboxylic acid is employed in textile treatment and as an acid reducing agent. So formic acid is used in textile industry for textile treatment, and also it is used as acid reducing agent. So what is the functional group? At the right side you can see COOH. So that is the functional group of carboxylic acid. The simplest form of carboxylic acid is a formic acid, that is HCOOH. The next very important functional group of the carbon, that is halogens, right? You have the halogens. Halogens are our friends from group 7 in the periodic table. So when you see the periodic table, in group 7 you have halogens, right? Like we have fluorine, chlorine, bromine, iodine. So these are some of the halogens which are present in the group 7 of the periodic table. Halogens are common functional groups. They are very common functional groups for alkanes. So most of the alkanes hydrocarbon have the halogens as the functional groups and can be used. They can be used in reactions to reduce an alkene into an alkyne. So to move alkene to alkane, you can use the halogens in the reactions. So these are some of the very important functional groups we have studied of the hydrocarbons. We will move on to the most important part, that is question and answers. Which of the following is used in making smoke bombs. So you have options: sulfur, phosphorus, hydrogen, and carbon. So which of these are used in making smoke bombs? Any answers? Is it sulfur, phosphorus, hydrogen, carbon? Okay, so it's a carbon. What's the answer? It is a carbon. That is option 4, carbon. A smoke bomb is a firework designed to produce smoke upon ignition. Smoke bombs are useful to military units, airsoft games, paintball games, self-defense, and pranks. Smoke bomb was first created in the year 1848 by the inventor, that is Robert Yale. So this is about the smoke bombs. Basically, we use the carbon for the making of smoke bombs. Which among the following coal contains 90% of carbon? So, anthracite, bitumen, lignite, or peat. So, which of the following coal contains 90% of carbons, right? Any answers? Which of the following contains 90% of carbon? Okay. You have answer, that is a first option, anthracite. So coal is a combustible black or a brownish black sedimentary rock occurring in a rock strata in a layers of veins called as coal beds or coal seams. The harder forms, that is the harder forms of a coal, anthracite coal, can be regarded as a metamorphic rock. It can be regarded as a metamorphic rock because of later exposure to elevated temperature and pressure. So this anthracite is a form of a coal which consists about 90% of carbon. We'll move to the next one. Which among the following is a right? So you have options. Which among the following are the carbohydrates? Is it nylon, cane sugar, turpentine, or hydrogen peroxide, right? So any answers out of the four, which of the following is a carbohydrate? Okay. Okay, let us see the answer. So it's a cane sugar, right? It's a cane sugar. It's a kind of a carbohydrate. Cane sugar is a carbohydrate, as this name implies, is composed of carbon, hydrogen, and oxygen. So it is consists of carbon, hydrogen, and oxygen. It is a source of extracting sugar. There are various types of sugar derived from different sources. Simple sugars are called monosaccharides and include glucose, fructose, and galactose. So these are some of the simple monosaccharides. The main constituent of natural gas is, so you have four options out of this, which is the main constituent of natural gas. Is it methane, ethane, butane, or propane? So which of these is a main constituent of natural gas? Okay, any answers? Which of these are main constituent of natural gas? Okay, so it is a methane. What is the answer? There is a first option, that is a methane. Natural gas is naturally occurring hydrocarbon gas mixture consisting primarily of methane with other hydrocarbons, carbon dioxide, nitrogen, and hydrogen sulfide. So this is a composition of a natural gas. So mainly it consists of methane. So next one, which of the following is a major constituent of LPG? So we know LPG, right? So which is a major constituent of LPG? You have a four options. What is LPG? Liquid petroleum gas. So four options, that is methane, ethane, propane, and butane. So out of these four, which is the major constituent of LPG? Okay. So any answers about it? Major constituent of LPG. Yeah. So it is a fourth option, that is butane. What's the answer? It is a fourth option, that is a butane. Butanes are highly flammable. They are highly flammable, colorless, easily liquefied gases. When blended with propane and other hydrocarbons, it is referred to commercially as LPG, for liquefied petroleum gas. So this is about the LPG. Wax used for making candle is chemically a mixture of, right? We use the candle, so we use the wax. It is chemically a mixture of aliphatic hydrocarbons, secondly aromatic hydrocarbons, or it is cyclic hydrocarbons. Lastly, is it aliphatic and aromatic hydrocarbons? So wax, it is chemically a mixture of what of these? So any answers? You have four options. Is it aliphatic, aromatic, cyclic, or is it aliphatic and aromatic hydrocarbons? Okay, so we'll see the answer. So it is the first option, that is aliphatic hydrocarbons. So what is the answer? Aliphatic hydrocarbons. Yes. Waxes are organic compounds that characteristically consist of long alkyl chains. They usually consist of long alkyl chains, hydrocarbons, lacking functional groups. They do not have functional groups. Waxes are biosynthesized by many plants and animals. They typically consist of several components, including wax esters, wax acids, wax alcohols, and hydrocarbons. Petroleum consists of a mixture of, right? We have an idea of petroleum. So it consists of a mixture of carbohydrates, carbonates, hydrocarbons, or carbides. So what does it consist of? So any idea about it? So it is a mixture of carbohydrates, carbonates, hydrocarbons, or carbides. Okay, so it is a third option. So that is a hydrocarbons. Petroleum consists of a mixture of hydrocarbons. So let us see the answer. It is about hydrocarbons. Petroleum from Latin word that is petra, that is rock, plus oleum. Oleum in the sense oil or crude oil is a naturally occurring flammable liquid consisting of a complex mixture of hydrocarbons of various molecular weights and other liquid organic compounds that are found in the geologic formations beneath the earth's surface. So this is actually petroleum derived from a Latin word petra and oleum. Find the odd one. So you have four options here. So you have to tell me the odd one. First one marble, secondly chalk, thirdly limestone, and last is a calcium. Okay, so you have four options: marble, chalk, limestone, calcium. So out of this, which is an odd one? Okay, so we'll see the answer. That is calcium, obviously, right? It is the fourth option, that is a calcium. Why it is calcium? We'll see. Calcium carbonate, that is CaCO3, is found in natural forms as a chalk, limestone, and marble, produced by the sedimentation of the shells of small fossilized snails, fish, and coral over millions of years. So, here in the above four options, the first three consist of calcium carbonate, whereas the fourth option is a calcium. So, it is a odd one. Which one of the following organic compounds has fruity smell? So you have a fruity smell, right? So which of these organic compounds? Is it alcohol, aldehyde, ester, or ether? So which of four options have fruity smell? Okay, any answers? Alcohol, aldehyde, ester, or ether? Okay, so it is a third option, that is a ester. Ester has a fruity smell. Esters are common in organic chemistry and biological materials and often have a characteristic pleasant fruity odor. This leads to their extensive use in fragrance and flavor industry. Ester bonds are also found in many polymers They are also found in many polymers. Esterification is the general name for a chemical reaction in which the two reactants, typically an alcohol and an acid, form an ester as the reaction product. So esterification is a very important reaction in which an alcohol and acid react to form a ester. So here ester has a fruity smell. Lead pencil contains, so we all use the pencil, right? Lead pencil contains lead, ferrous sulfide, lead sulfide, or is it a graphite? So we studied about it. Lead pencil contains lead, ferrous sulfide, lead sulfide, or graphite. Okay, any answers about it? What does it contains, lead pencil? Lead, ferrous sulfide, or graphite, right? So here the right answer is the fourth option, that is a graphite. Lead pencil contains graphite. Yes. Most pencil cores are made of graphite mixed with a clay binder, leaving gray or black marks that can be easily erased. Graphite pencils are used for both writing and drawing, and the result is durable. So we use the pencils for writing and drawing. So it mainly consists of graphite. Water gas is a mixture of, we have a water gas. So what does it consist of? Is it a mixture of carbon dioxide and hydrogen, carbon monoxide and a nitrogen? Is it a carbon monoxide and hydrogen, or carbon dioxide and nitrogen? So you have four options here. So water gas is mixture of what of these? Is it carbon dioxide and hydrogen, carbon monoxide and nitrogen, carbon monoxide and hydrogen, or carbon dioxide and nitrogen? Any answers? Okay. So let us see the answer. It is a third option. It is carbon monoxide and hydrogen, right? So water gas is a mixture of a carbon monoxide and hydrogen. Water gas, a mixture of carbon monoxide and hydrogen, is produced by treating carbon in the form of a coke or a coal with a steam at a high temperature. So this is how it is synthesized in lab, by treating the carbon with a steam at a high temperature. So let us move to the conclusion part. So in this chapter, you learned recognized carbon, and we appreciate the existence of large number of carbon compounds. We also studied the sources of carbon compounds and some of the allotropes of carbon and studied their properties, described the preparation of oxides of carbon, and recognize the most important property, that is catenation. We also studied about saturated and unsaturated hydrocarbons and recognized the different functional groups. And we also appreciate that organic compounds and some of their uses. So this is what we studied in today's class. So if you have any questions or queries, you can ask me. You can also visit to edurapid.com site, Few more questions will be there. Please practice and prepare for your exams.